of the entire egg weight and contains plenty of vitamins and minerals. The color of the yolk is dependent on the hen's diet. Eggs from pasture-raised hens are said to have more omega-3 and less cholesterol due to its consumption of natural feed.
Welcome to another beautiful Tuesday afternoon. Yes, you are with me, Tobile Nkosi. And today we'll be doing physical sciences. We will be looking at paper number 1. I want to send tons and tons of love and a big hug to Liberty. Thank you so much for spending the show, for sponsoring the show, and for actually giving us the platform to actually help the class of 2021 with their final exam papers. And grade 12s, if you haven't done it yet, please do download the Tenfold education app. It is an app filled with tons and tons of past papers that can help you guys prepare for your final exam. Remember, the more you practice physics and mathematics, the better that you get at it. And remember, if you're wondering what question paper we're doing today, please do send a hi on the WhatsApp number on the screen and you'll meet our friend Dex. And just like you, he wants to learn. Another platform we are very active and productive if you need more help is on YouTube. You're more than welcome to follow us on YouTube on the link below. And on YouTube, we are then called Mindset Learn. So without wasting any more time, I'm doing revision for paper number 1 for the final NCS. And in today's show, we're doing Newton's law. So I'm going to show you the tricks and trades of these questions. And another thing, if you are grade 11, it's very important that you also sit down and listen, because this is the same content that we learn in grade 11, but it's also taken over to grade 12. So just in case you're in grade 11, not kind of understanding what's happening, you're more than welcome to watch. So the first question that we're going to do, it's question number 2. So most of the time, Newton's laws will be question number 2. So that question says, in the diagram below, a small object of mass 2 kilograms is sliding at a constant velocity. Now, when you're reading physics concepts, it's very important that you actually underline some of the wording that's actually there. How I always teach my kids is to always have a highlighter, and then you underline the words, and then you will see every time there is that word, there's a certain procedure, process that you need to use to answer the questions. For example, if they say constant velocity, now we know the velocity is not changing, so the initial and the final is exactly the same because it's constant. Now we learn about equations of motions in grade 12, in grade 10, and that's where we introduce constant velocity. If the velocity is constant, then acceleration is 0. Right? If the velocity is constant, then acceleration is 0. Now you're going to see where I'm going to put that into play. So also when you're reading some concepts and it says it's sliding down, there was no force applied, there's no tension and so forth, and you know that only the force of gravity is then working on the object. So these are some of the key notes that you need to look at. So in this case, they're telling us that it's sliding at a constant velocity of 15 meters per second down a rough. Now, the minute they say a rough plane, and I can see it's first at an angle, then it's on a horizontal plane. But what does the word rough tell me? The word rough tells me as it's sliding down, I've got frictional force in the opposite direction that's trying to slow the block down. Remember, if the minute it says rough, we've got frictional force. If they say on a smooth, frictionless surface, no frictional force, right? Think of it like ice, you know, it slides. But the minute they've got rough, you know that there's going to be an opposing force of motion in the opposite direction, which we call friction, that is going to slow the block down. So that's something else to keep in place. And it's on an incline at 7 degrees to the horizontal surface. So I see here's my block and it's moving down. This is a nice diagram. So we continue to read that at the bottom of the plane, so I can see that from here it moves to being an angle, on this place where it says the horizontal, this means the bottom of the plane, right? I just want to include something else. Now, if something is sliding down at a certain angle, then we have to use FG, sine, parallel, cos theta, and so forth. But if it's on a smooth horizontal surface, we have to use equations of motion. So now you already with this picture can see how we're going to move from Newton's laws all the way to equations of motion. Because first it's at an incline, and then it's on a horizontal surface. Now we know if something's on a horizontal surface, there's initial velocity, there's final velocity, acceleration, time, and so forth. So at the bottom of the plane, the object continues to slide onto the rough horizontal surface. I can already see that on the incline, as well as on the horizontal surface, there's frictional force. Surface, and it eventually comes to a stop. Now we know if something is sliding down and it's moving and it's moving and it's moving, it comes to a stop. It means that the final velocity of that object then also becomes zero. So that's what the stop means. So you already have to take that into consideration. They continue to tell us that the coefficient, remember coefficient is just like a ratio. What's the ratio of the frictional force to the surface? So the coefficient of the kinetic friction between the object and the surface is the same for both the inclined surface as well as the horizontal surface. This just means that the frictional force in this part here and in this part here will be the same, which means that the surface does not change. So the ratio or the coefficient will then be the same. Number 2.1 says, write down the magnitude of the net force acting on the object. Now I'm going to do it the long way around so that you know where I'm coming from. If you can already see this question, it's only for 1 mark, so the examiner just wants to see one thing. The minute you see questions only for 1 mark, it has to be something in the statement, or it has to be a physics law that was said or that you've identified. In this case, let's calculate net force. All the time when we're calculating net force, we always say F net is equal to MA. I want to go back to the statement below. All the way up, they told us it's moving at a constant velocity. When velocity is constant, acceleration is 0. Because remember, in grade 10, we learned acceleration is V final minus V initial over delta T. So this means acceleration then becomes 0. Let me do it the long way around so that I can just show you how we get that. MA, that will be 0. Anything multiplied by 0 is 0, which means that F net is also equal to 0. And that was only for 1 mark. So the examiner wanted to see when you're reading the statement constant, and most of the time they will underline it, they'll write it in capital letters, or they will write it in bold to remind you that if the velocity is constant, then the acceleration is 0. There you have 1 mark for that. So you don't really have to do the long step that I did, but I just wanted to show you where that comes from. You could have just said F net is equal to 0. If they do ask for a reason, then because velocity is constant. Then they tell us to draw a free body diagram of the object while it is in the inclined plane. Now there's 2 things. In grade 10, we introduce vector diagrams where we draw a block and we show all the arrows, as well as grade 11. And then in grade 12, we also include a free body diagram. Do not make the mistake to confuse a vector diagram with a free body diagram. A vector diagram is a block and a free body diagram is represented by a circle. In this case, I see I've got 3 marks. Now, when you're reading a question about free body diagrams or vector diagrams, the mark allocation will tell you how many forces you need to have. So in this case, you can actually never get it wrong. In this case, I've got 3 marks, meaning I've got 3 forces. I've got an object sliding down. I know that it's on a rough surface. There has to be a normal force, and there has to be gravity. There was no force applied. There's no tension that is applied to it. It's just sliding down. So I'm going to do it in 2 ways where I actually break up the components and show you. Remember, it's on an inclined plane. If you do struggle with drawing inclined planes, I would draw it with a pencil, like that, fill in all the forces, and then erase it. Or you can just use a ruler. Always use a ruler. So for 3 marks, let's see. Remember, I just want to go back to this diagram here. It has to be in this angle. Don't change your inclined plane in the other way around. No, you don't want to do that. Keep it in the same direction as it is. So there's my dot, and I know as it's sliding down, I'm going to have my normal force, which is my F of n. They did tell me that it was on a rough surface. So that is my kinetic friction. Remember, they did say kinetic friction. There's the difference between static friction and kinetic friction. Static friction would have been Fs, and kinetic is then Fk. So show the examiner that you are reading everything that they have there for you. And then I do know that we'll also have the force of gravity. That will then be Fg. However, you can then choose to break the components of Fg into the components of Fg parallel and Fg perpendicular. Again, I'm going to have F of n, which is my normal force. They did say it's on a rough surface, which means we have frictional force. The statement said coefficient of kinetic friction, so it's Fk. I'm going to break up the components of Fg. Remember, they did say that it's sliding down, so that will be Fg parallel. And in this direction, this will be Fg perpendicular. Now remember, if the examiner is going to mark, you get a mark for this, you get a mark for that, and these two only count 1 mark. So then that's how the examiner gets 3. However, my darlings, if you do decide to draw it like this and you break up the forces already, that is not very right. You're going to go through what we call negative marking. So please just make sure that you either write down F of g or you break up the components of F of g. But don't write everything. That is very, very incorrect. You have to choose one. So then I'm going to just leave them like this. And then that will then be your free body diagram for that. That's for 3 marks. And if you did it like this, then you'll get a mark for each one. Remember, if you do break them up, these 2 count for 1 mark. So then you are safe there. Now we're moving into some calculations. They're telling us that we must calculate the magnitude. Remember, the word magnitude in physics is just a fancy way to say size. So calculate the size or magnitude of the frictional force. Remember, they told us it's on a rough surface, so the frictional force acting on the object while it's sliding down the inclined plane. Again, this is for 3 marks. So let's see what we're going to get here. Remember, every time you have to work with Newton's laws, especially if something is on an inclined plane or any other law for Newton, matter of fact, always start with a formula, right? And I'm going to show you how you can actually use your formula and then incorporate your free body diagram in order to answer the question. So let's see, we must calculate the frictional force. Now remember, when we're calculating forces according to Newton's, we always say F net is an equal to ma. Now remember, in the previous statement, we were told it's a constant velocity. So F net is now also equal to 0 because acceleration is equal to 0. However, I know that if the object is sliding down, I'm going to have frictional, kinetic friction, as well as Fg parallel that is making this object move. In this case, I'm going to break up my F net into 2. What is making the object move is Fg parallel, that's parallel to the surface, minus the opposing force of motion, which would be my kinetic friction, which will then be my Fk, is what's equal then to ma. Now I'm going to break this up a little bit further because I am looking for my kinetic friction. So now my Fg, now you can choose to do it in 2 ways. You can either calculate your parallel force on the side, but show the examiner that you've calculated it because you're going to get marks for it, or you can do it all in one step. I'm just going to do it all in one step. It's a little bit easier for me. So I'm going to break this up first. Remember, when we're calculating Fg parallel, we use mg sine theta. I'm looking for the kinetic friction, and we do know they said constant velocity. When the velocity is constant, acceleration 0. Anything multiplied by 0, this also gives me 0. Now I'm going to plug in what I'm given. The mass of the block that's sliding down is 2. The gravitational acceleration is 9.8. Remember, that is a constant that you can also find on your formula sheet. The angle of the incline is 7. And I'm just going to take this to the other side so I can already calculate the FK. I'm just going to say FK on this side, and then I'm going to put this, all that in my calculator exactly as it is. Remember to put brackets around everything, so that's 2 times the gravitational acceleration. And then I'm going to say sine of 7. So therefore, I get 2.39. Remember, always to 2 decimal places in physics and in chemistry, unless stated otherwise. If the third number is 5 or greater, then it rounds off the one before it to its next value, and that's how I get 2.39. Now remember, friction is a vector quantity, so it's got magnitude and direction, and therefore it will be a capital N as the SI unit. So this is then for 3 marks. Remember, for this one, you could have done it on the side, somewhere here, and then just plug it in or move on, or you can do it all in one step. So either one is perfectly fine. Now, they continue to say we must calculate the coefficient. We must calculate the coefficient. Remember, coefficient is like a ratio, so we're looking for that funny-looking sign. We're looking for that FK, coefficient friction between the object and the surface. Remember what I always say, in physics, you must always start with a formula. The minute you have a formula, you are then able to kind of work yourself backwards to see what you have, what you don't have, and what you're actually in search for. So the formula for calculating friction, that's where I'm going to start it. I'm going to say Fk, they did say kinetic friction, the coefficient of kinetic friction multiplied by N. Remember, N is then the normal force. We still need our free body diagram to answer this one, so I'm going to go all the way up. The normal force is equal to Fg perpendicular, right? So I can therefore substitute the Fn on my formula with the Fg perpendicular because they're opposing forces. I'm just going to plug it in exactly like that. So I'm going to do it the long way around so everyone knows exactly what I'm doing. The coefficient, this one will be Fg perpendicular. I'm going to do it another step. And then you can then just break this up as mg. When we're using perpendicular, we use cos theta. So you can use any one of these and then start plugging in. If you feel like you're getting a bit confused, use everything. Just don't take too much time, but then it makes perfect sense. We just calculated that one. It is 2.39. Now remember, if you feel like your kinetic friction is wrong in the previous answer, don't suck thumb any other answer, then plug it in there. Use that kinetic friction in the correct equation here, and the examiner will then give you marks because it shows the examiner that even though the previous one was wrong, you understood precisely that that answer needed to be plugged in into this step. So continue like that. Now I'm going to plug in my answer, the one that I got before. So for my kinetic friction, I got 2.39. I'm looking for the coefficient. The mass of the object is 2, gravitational acceleration is 9.8, and now I'm going to use cos of 7 because the incline was then 7. I need to find my coefficient. I have to divide both sides with what's bothering the coefficient, so I'm going to end up with 2.39 all over what is here at the bottom, and I'm going to have cos of 7. So let's put that in my calculator. And let's see what we get. So remember to put brackets around everything. I cannot stress that enough. 2.39, and then I've got 9.8, and then I've got cos of 7 because that's the incline that we were given. 7, and then I therefore get 0.12. Yes, the 2 is less than 5, so it will not make any effect. So that's 0.12. Remember, the SI unit for coefficient is no unit, it's just a ratio. So you leave it as 0.12. So let's look at the next one. Aha, now they're talking about distance. So this question says that I must calculate the distance. Now, I know when I'm talking about distance, there's various ways in which you can calculate distance, especially when we're using in physics. right? In this case, for me, I think it might be equations of motion, unless that we're talking about work, energy, and power, then there's other ways to do it. But distance most of the time is then equations of motion, especially because they said the object comes to a stop, meaning that the final velocity is then 0. So let's read. We must calculate the distance the object travels on the horizontal surface before it comes to a stop. So let's see here. I just want to go back up to the diagram. Now we know that it slides all the way down. Somewhere imaginary here, the final velocity of this object will be 0 meters per second because it has come to a stop. We need to find out the distance between these 2 points here. So let's calculate that. So I think our first step would be, we need to find the acceleration of this object. So I would first say, I just want to take you back a little bit. When you use equations of motion, we can use this equation over here, plus 2a delta x. I'm looking for the distance it travels. I do know that my final velocity is 0. I also know that my initial velocity was 1.5. I don't have acceleration. And in physics and mathematics, actually, you cannot have two unknowns, especially because we cannot do a simultaneous equation with this one. Or maybe I haven't tried it, but for me, it doesn't look like you can. But you cannot have acceleration unknown, and you cannot have distance unknown. So we have to find the acceleration, and then we are able to then put it in, plug it back in. So let's calculate this object's acceleration. I can therefore say F net, because I know when we're talking with Newton's laws, we are then able to use the formula F net because it has acceleration. So now remember what they told us, that it is sliding down the incline. It's sliding down where it has a constant velocity, and then it gets to the horizontal surface. So now as it gets to the horizontal surface, they didn't say anything about constant velocity. Now we know that it gets to this point and then it starts moving in that direction. In this point, it was sliding down at constant velocity, so acceleration was 0. But when it gets to this point, which I've named point B, and then it can have acceleration because it does come to a stop, so there is a change in velocity. Let me just go down. So let's find out what we have. Then again, I am then able to say, in this case over here, the F net of the object, I can also say is equal to negative Fk. Because remember what they said. They said it's moving on a horizontal surface. It's moving on a horizontal surface and it's just sliding down. The only force that's working on it, because it comes to a stop, is the kinetic friction. I know that kinetic friction is opposing motion, so I leave it as a negative. I'm going to break up this one. Just want to write it here. Remember, when we're looking for kinetic friction, we have the coefficient of kinetic friction multiplied by the normal force. So which means that Fk is equal to the coefficient and the normal force, which I'm going to then substitute here, which is the negative of the coefficient. Normal force is equal to Ma. Now I'm going to start plugging in everything that I'm given. Remember, there's a negative. So I'm going to break it up as the coefficient is 0.12. Why am I using 0.12? In the previous statement, we were told that the kinetic friction on the inclined plane, so this kinetic friction here and this kinetic friction here is exactly the same. So that's why I'm able to take the kinetic friction I found on the inclined plane and use it on the horizontal plane. So I have my 0.12. And now remember, if the object is now on a surface like this, I have a normal force here. In the opposite direction of that, I've got Fg, and I can break up Fg as mg, right? The mass and gravitational acceleration. Only when an object is on an incline, let me just write that F of n, then do I use the Fg perpendicular. But in this case, it is on a horizontal surface, so I just use Fg. So my normal force is mass times gravitational acceleration. The mass of the block that I'm given is 2. The gravitational constant is 9.8 equal. The mass of this object is 2, and I'm looking for the acceleration that it will have on the horizontal plane. I'm looking for acceleration. I'm going to have to divide both sides with what is bothering the acceleration. So I'm going to have to divide both sides by 2. This and this will cancel. And then I'm going to have to, remember now again, the acceleration needs to be a negative because it's decelerating. It's getting less and less and less until it comes to a complete stop. So I'm going to put everything exactly as it is in the calculator. So you can put the negative outside or inside, or I'm just going to skip it because I know a negative multiplied by positives will still remain a negative. And that will be a 2, that will be 9.8, and all of that will be over 2. Therefore, for my acceleration, I get 1.18. Remember, the third number is 5 or greater. It'll change the 7 to its next value, which will give me 1.18. Remember, it is a negative, so this will be negative 1.18. Remember, the SI unit for acceleration, do not confuse this with velocity. It is therefore meters per second to the exponent negative 2. However, I'm not done. They did say distance. So now I can see for my equations of motion, you could have used any other one. Some of them you have needed time, so I just shied away from that one. Now I have my acceleration, there we are, and therefore I can then find my distance. Now I'm just going to plug in. Remember, formula first, and this was for 5 marks. So final velocity squared, the object's initial velocity plus 2a delta x. They did say it comes to a complete stop, so my final velocity is 0. Initially, the block was moving at 1.5, and that is squared plus 2, the acceleration I just calculated right now. Remember, it is a negative because it's decelerating, 1.18, and I'm looking for delta x. So I'm going to do this. I want to put it all once in my calculator. You can actually do it and keep breaking it up and so forth. But one thing you must remember, if you're going to work it out and then write an answer, carry it over and so forth, you must write the whole number. So if you get something with 14 digits from the calculator, you must write those 14 digits. So what I always teach my kids, to be on the safe side, don't keep rounding it off because it just makes your answer more wrong. Otherwise, you can make what you're looking for the subject of the formula, and then you put it in your calculator all at once. And everybody is a happy teacher. So that's what I'm going to do. So what I'm going to do, I'm going to take all of this to the other side. So I'm going to have the 2, which changes into a negative. Remember, if you multiply a positive and a negative, it's a negative. Taking over the negative becomes a positive. That's 1.8. And that's delta x, and I'm still going to have 1.5, and that is then squared. Now, I need to divide both sides with what's bothering my delta x, and that's 2 and 1.18. What you do on the one side, you have to do on the other side. So this and this will cancel. So I'm going to put this in my calculator exactly as it is, and let's see what answer we get. So remember to put brackets, so that will be 1.5, and that is to the exponent 2 because it is squared. At the bottom, I've got a 2 multiplied by 1.18, and therefore I get 0.95. The third number is less than 5, so that's 0.95. So delta x is 0.95. Now remember, the SI unit we use for distance is then in meters. And then I think that was our last question. But as you can see, I've answered this question. You actually have to look at your scenario, psychoanalyze what the examiner has said, because all your answers are there. And unfortunately, some of the key words with physics are what can actually make or break your paper. For example, when they talk about constant velocity, something that is sliding down, the distance it will travel on the horizontal surface, then you need to start picking up those points to what do you need to do, what are they referring to, and how do you then get to the answer. But nonetheless, let's go for an ad break, and I'll see you after the break.
Did you know that the lighter was invented before the match? A German chemist named Johann Wolfgang is credited with inventing the first lighter in 1823, which worked through a reaction of hydrogen to platinum sponge. It wasn't until 3 years later, in 1826, that the first modern match appeared, when Englishman John Walker invented a match that would ignite through friction.
No one ever asks why we do the weird things we do. Like, why once is never enough. or doing 2 trips is just one too many. Why do we, before we use these, or say 5 when we mean 20, why do we have second thoughts and think that lift buttons make them go faster? Why don't we walk there, cross our fingers, touch wood, and struggle to hide our true feelings? At Liberty, we want to know all the weird and wonderful things that make us human, because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Welcome back to another beautiful Tuesday afternoon. You are still tuned in with the Tenfold Live, and I am Pulley. Just want to send another big shout out to Liberty. Thank you so much, guys, for sponsoring the show. Thank you for giving us this platform and this opportunity to actually help the class of 2021 fulfill their dreams and actually pass grade 12 with physical sciences. Another thing, grade 12s, if you haven't done it yet, please do download the Tenfold Education app. It's an app filled with tons and tons of pictures of past papers that can actually help you prepare for your final NCS papers. Another thing, if you're wondering what question paper we are doing and you'd like to join in the fun, please do send a hi to the WhatsApp number on the screen and you'll meet our friend Dex, and then we shall then send you the question paper we are doing. Another platform where we're active and where we can actually help you guys is on YouTube. Please do follow us on YouTube, and there we are then Mindset Learn. So in today's show, we are looking at Newton's laws. So now, in the previous question, we looked at an object on an incline and how it then slides on a horizontal surface, drawing free body diagrams and so forth. So now it's the same thing, but a whole different ball game. Now we have something on a table. So we've got 2 objects. One is on a table, one is hanging down. We've got distance and all that stuff. Now, dun, 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 dun. When you are doing paper number 1 in grade 12 and you see 2 objects with a pulley system that are pushing each other or pulling each other, you need to know there's going to be a simultaneous equation. Simultaneous equations can be a little bit tricky if you do not draw your free body diagram right. So I'm going to show you how you actually do all of that and how you get to the correct answer. So let's read what this one's about. So we're first told that a 5 kilogram mass and a 20 kilogram mass are connected by a light inextendable string. So it just means that the length of it doesn't change, it remains the same, of string which passes over a light frictionless pulley. Initially, the 5 kilogram mass is held stationary. So here's another word. When something is stationary, think of it as standing still, meaning that the initial velocity is 0, right? Stationary means initial velocity is 0. So it's stationary on a horizontal surface, while the 20 kilogram mass hangs vertically downwards, 6 meters above the ground, as shown in the diagram below. So the diagram is not drawn to scale. So this is the scenario that we are having. Now already just before continuing, I can already see that, okay, here I'm going to have tension and, it's frictionless here, and this one is hanging. So here we're going to have gravitational acceleration. So I can already prepare myself with what needs to be happening. Then it continues to say, when the stationary 5 kilogram mass is released, the 2 masses begin to move. Now, we're not really sure in which direction they move yet. The coefficient of the kinetic friction between the 5 kilogram mass and the horizontal surface is 0.4. So now I know that the surface which this 5 kilogram block is not a smooth one. It's rough, and meaning that there is kinetic friction. So we must also ignore the effects of air friction. So that's what we are told. So now I've got tension as well as kinetic friction. So the first question, number 2.1, says I must calculate the acceleration of the 20 kilogram mass. So now I can already see the acceleration. I can't just calculate it by mere looking, because this one is released, the 5 kilogram block is released, and then they both start to move. So it means it has to be a simultaneous equation, and I can see that this is for 5 marks. So I'm going to do it the long way around for you guys. So step number 1, I'm going to draw free body diagrams. Okay, let me actually just number it properly so that everyone sees or knows what I'm doing. I'm going to do the 5 kilogram block. and I'm going to look at the 20 kilogram block, and I'm going to do their free body diagrams. Remember, it's represented by a dot. If you are able to see the equation without doing the free body diagram, then you're more than welcome to. I do show my kids this because 99.9% of the chance you will not get it wrong. The 5 kilogram block, there's normal force. We do know that we'll have gravitational force. There is a string on this side, which will be my force of friction. They already told me about the coefficient of the surface, so it means that we'll have frictional force on this side. On the 20 kilogram block, I know that I've got tension moving this in this direction, and then I've got Fg moving in that direction. Now I have to start working with mathematics. Let me start here. For the 5 kilogram block, remember when we work with Newton's laws, we always start with F net is equal to ma. F net, so the sum of all the forces that are working on the 5 kilogram block, it is tension, and we also have frictional force opposing that motion. Therefore, I will then say tension minus the frictional force is also equal to ma. We were told nothing about moving at a constant velocity, so we do keep this as ma and we don't say 0. I don't know my tension, and my friction I also don't know. The only thing I am told is the coefficient of kinetic friction. So you can also do it in one full step, or you can do it step by step. I'm going to calculate it over here, and then I'm just going to plug it in. It depends on you. Remember, it is Fk. I'm looking for the coefficient of kinetic friction, and then my normal force. Mut is I'm given, or the coefficient is 0.4. The normal force is equal to mg because it's not on an incline. Had it been on an incline, then the normal force would be equal to Fg perpendicular. So the normal force is the mass of the object, which is 5, multiplied by the gravitational acceleration, which is 9.8. So let's see what was the frictional force over here. So that's 0.4 for the coefficient. The block has a mass of 5 minus the constant of 9.8, and therefore I get 19.6. I get 19.6. The SI unit for friction is then a capital letter N. So this means that my friction force, I'm just going to plug it in there. Remember, I don't have tension. I just calculated my frictional force as 19.6. The mass is 5, and I'm looking for acceleration. So this will be equation number 1. For the 20 kilogram block, remember when we do Newton's laws, it's F net is equal to ma. Now let's look at, remember net means, net and resultant means the sum of. So all the forces that are acting on the 20 kilogram block, I've got tension and I've got gravitational force. Here comes the trick. If tension was positive on this side, then tension must be negative in the 20 kilogram block so that they can cancel. In this case, I'm not going to say tension minus gravitational force since they're opposing each other. I'm going to say force of gravity minus tension, so that tension is a negative. I'm going to have Fg minus the tension is then also equal to ma. My force of gravity, that is easy. It is the mass of the object, which is 20, multiplied by the constant of 9.8, minus tension, was a little bit too quick there, minus tension is equal to the mass, which is 20, and then my acceleration. I'm going to work that out just to make things a little bit easier for me. So that will be 29.8, and therefore I get 196. So it will be 196 minus tension is equal to 20a, and this becomes equation number 2. So now various teachers use different methods with this one. For example, I know educators who write everything on the left-hand side in one equation, and then write everything on the right-hand side only as one equation. Some teachers will subtract the first and the second, some will add the first and the second. I'm one of those teachers. I add equation 1 to equation 2. But depending on how your teacher has actually taught it to you, if it makes sense for you, if it's easier for you, you're more than welcome to carry on with it. So I'm going to add the 2 equations. I always try or like to write everything underneath each other. That's minus 96, and this is equal to Fa. That's my first equation. I've got an equation sign there. I've got 20 on this side, 196 minus tension. I'm going to add the 2. There we are. A positive t plus a negative t, that will cancel. That gives me 0. Now I'm going to do this one. So I've got negative 19.6, and I'm adding 196. And if I add that, I get 176,4. I get 176,4 equals, this one I can do with my head. 5 plus 20 will give me 25A. 5 apples plus 20 apples gives me 25 apples. Now that I'm looking for my A, I divide both sides with what's bothering my A, and that is then the 25. And therefore, the 25 and 25 will cancel. So my value for my acceleration, I'm just going to take it as it is, divide that by 25. And I find my acceleration as 7,06. Yes, the third number is greater than 5. So therefore, I get 7,06. The SI unit for acceleration is meters per second squared. So there I've calculated the acceleration for the 20 kilogram block. Let's look at the next one. Now they also want us to calculate the speed. Now remember, when they're talking about speed, they are talking about equations of motion. We must calculate the speed of the 20 kilogram block or mass as it strikes the ground. So I just want to go back to the diagram. So the 5 kilogram mass is released and it goes and then it hits the ground. So now they want to know the speed at which the 20 kilogram block actually moves down and hits the ground. So there are various things that we do know. We do know that it was traveling, the initial velocity was 0 because they did say it was at rest and then it was released. So calculating speed, you can use the various amounts of the equations of motion depending on which one you like. I just want to stipulate a little bit on that one. If you have to use equations of motions, guys, open your formula sheet and then try to find one that prevents you from first finding the time and then the acceleration and then this one. In case your time is wrong and you're plugging it in and then all that stuff, then it makes everything wrong. Rather use an equation whereby you are able to use values that the examiner has already given you. Then you have less chances to actually make a mistake, and you're actually able to see whether something makes sense or it doesn't. But if you first have to find the time, you cannot confirm if that is right. Then you must find the acceleration. You also can't confirm that is right. So how do we know that the final answer is right? So in this case, this is the one that I've chosen because it just was a little bit easier for me. V squared is equal to VI squared plus 2A. And remember now, the block is hanging. So we use delta Y. In the previous equation, it did move on a horizontal surface like the block. We use delta X. Please be very, very careful with that one. So this is 2A delta Y because it is hanging. So the final velocity is what we are looking for. So I'm looking for VF squared because they want the speed at which it hits the ground. Initially, they said they were at rest, right? Meaning that something is not moving. I've got a 2, the acceleration at which it moves it. We just calculated the acceleration in the previous equation. And then again, if you kind of sort of think that your acceleration might be wrong in the previous answer or previous question, please use that acceleration to plug it into this one because you're showing the examiner that you do know that these two blocks will then move with that acceleration, or the 20 kilogram block will move with that acceleration. So plug it in correctly and then you're showing the examiner you know exactly what's going on. I'm going to use my acceleration. Even if you think it's wrong, please just use it. And then delta Y will be 6. They did say it is 6 meters above the ground. VF squared, I'm going to put this side in my calculator exactly as it is. Let me just move my calculator. So I'm going to have 2, 7,06, as well as 6, and that is the height at which it actually fell. And that is the answer that I get. But remember, it is squared. Just double check this one. I've got, I see I've got a K there. Just do it again. That's 2 multiplied by 7,06. And then I've got 6. So let's see what I have over here. I've got 82.72, yes. So that is 84,72. Now remember, it is exponent. So to get rid of the exponent, you put both under a square root. On this side, the square root and the exponent will cancel, leaving V final by itself. In this side, we have to put everything under a square root. So we got 84.72. Always write it to 2 decimal places, so we get 9,20. So the velocity at which it strikes the ground is 9,20, and the SI unit for velocity is meters per second to the exponent -1. Now let's see. This one is also for 1 mark. The examiners are trying to catch you out here. So it says, at what minimum distance from the pulley should the 5 kilogram mass be placed initially so that the 20 kilogram block just strikes the ground? Now think about it. So they told us that the 20 kilogram block was 6 meters above the ground. Now they're asking us, how far should the 5 kilogram block be away from the pulley so that it just strikes the ground, which means it should also then be 6. Because if you're looking at this diagram here, when the 20 kilogram block was 6 meters from the ground, it just struck the ground. And you can see that it's for 1 mark. It's only for 1 mark. So there's no calculation that needs to be done. So that also makes it then 6 meters. So as you can see, that the examiners will try all sorts in order to actually catch out, but you also need to look at the mark allocation to actually see how much work needs to be done. And then based on the mark allocation, then you can see whether is it something that you need to read, is it something they need to calculate, or is it theories that you actually need to know. So that's another question that we've done, and I'll see you after the ad break as we do another one.
Did you know that Africa is larger than the USA, China, India, and a large part of Europe combined? A standard Mercator world map does not accurately show the true enormity of the African continent. The continent is so big that the USA, China, and India could all comfortably fit within it. There would be enough space left over to fit Japan, Spain, France, Germany, Italy, and most of Eastern Europe in as well.
Welcome back from the ad break. Thank you so much for still tuning in. Yes, I am Tobi Lenkosi. Once again, I want to send a big shout out to Liberty. Thank you so much for sponsoring our show. Thank you for giving us the opportunity and the platform for actually helping the class of 2021. And grade 12s, if you haven't done it yet, please do download the Tenfold education app. It's an app filled with tons and tons of past papers that can help you guys prepare for your final NCS. And if you're wondering what question paper we're doing and you'd like to join in the fun, please do send a hi to the WhatsApp number on the screen and we shall then get back to you. Another platform where we're very active, productive, and really helping tons and tons of students is on YouTube. If you want to actually join us on that platform, please do follow us on YouTube, and there we are Mindset Learn. So in today's show, we're doing all about Newton's law. So we've looked at a few problems in how the examiner can actually spice up the question paper and how they can actually ask you. I've also shown you some of the interesting terminology that you can look out for that can actually make your life a little bit easier. So now we've got another problem that we're going to solve. And this one goes like this. So it says we've got an 8 kilogram block, which they've named P, which is being pulled. So now we do know, all the other ones were actually just sliding down and so forth. So now being pulled means there's an applied force by a constant force up a rough. Remember, we said the minute there's rough, we know that there's frictional force. Up a rough inclined plane at an angle of 30 to the horizontal at constant Speed. Can you see the consistency over here? We do know when the speed is constant, then acceleration is then 0. Because if there is no change in velocity, then acceleration is 0. So force F is parallel to the inclined plane as shown in the diagram below. So the first question that they've asked here was state Newton's first law in words. So I've just written it down for you so that we don't waste time. But Newton's first law in words says, an object continues in its state of rest or uniform motion, moving with constant velocity, unless it is acted upon by an unbalanced or net force. So that is for 2 marks. So what I always tell my kids, you cannot fail because you're lazy to read. So please do read all your definitions. Now, number 2.1.2 says, draw a labeled free body diagram. Now, we already went through a free body diagram and a vector diagram. Remember, mark allocation tells me how many forces I need to have. It is on an incline, so make sure that you do show it on an incline. So let's see where the first force will be. They did say it's being pulled by a constant force, which is F, so that is my first one. They did also tell me that it's on a surface, on an incline, meaning that there is a normal force. And then I can say we've got the force of gravity. But now remember, they did say a rough surface, which means I also have my Fk on this side, which is then my kinetic friction. Or you could have chosen to break up the forces of Fg. So if you do tend or want to break it up like that, you've got the applied force, which is constant. You have your normal force, which will be perpendicular to the surface. Now with Fg, we can break it up as, let me make it a solid line, to Fg perpendicular. And then in this direction, you're going to have Fg parallel. And also in that direction, you're going to have your frictional force, since they said it's on a rough surface. Remember, for 4 marks, the Fg parallel and perpendicular both count for 1 mark. So that's 1, 2, 3, 4. Or you can do it in this way, and that is then just 4 marks. So if you do it in this way, remember that you also have Fg parallel that is actually working on an object. So just keep that in mind. So let's move on. So they continue to say that the kinetic frictional force, so that we already told kinetic, so that is Fk, frictional force between the block and the surface of that incline is 20,37 newtons. Now they want us to calculate the magnitude of the force. Now remember, we are working with Newton's laws. This is for 5 marks, so we need to show the examiner exactly what's happening. Newton's laws, anything on an incline pulley system, we always start with a formula. So the formula will be F net is equal to MA. Now, which 2 forces will make up F net? I can see that there is an applied force that they're talking about. I have kinetic friction that will move in the opposite direction. I also have Fg parallel that will move in the opposite direction. So that's all the forces that are working in that direction. Remember when we talk about vectors in the same direction we add, and vectors in opposite directions we are then going to subtract. So I can see that my F applied, which is the force that's pulling it up, is the only one moving in that direction. So I'll have my applied force. Opposing the motion will be the kinetic friction. Also opposing the motion will be Fg parallel, all equal to, they did say, a constant speed. When speed is constant, then acceleration is 0. So it's all equal to 0. So this will all equal to 0. Now you can start breaking it up. Let me do it the long way around so that you can choose or decide from where you want to take it. My Fk I was given, Fg parallel, I'm going to use mg. Remember, it is on an incline, and that will then be sine theta is equal to 0. I'm looking for F. I was told that my kinetic friction on the surface is 20,37. The mass of the block is 8. Gravitational acceleration is a constant of 9.8. I've got sine, and it's at an angle of 30, all equal to 0. This means I'm going to take all of these values to the other side, and then I'm going to be left with F. Let me just do it. So I'm going to have 23.9. Remember, if a number jumps, the equation sign doesn't really jump, but the sign will then change. 9.8, and then I'm going to have sine 30. Yeah, Spasisa shouldn't hear me saying signs jump. You know, as a maths teacher, he wouldn't be impressed with me. And then we've got 9.8, and then I've got sine of 30. So then I find the force as 59.57. So this will be 59.57. Remember, the SI unit for force is a capital letter N. Therefore, I've done the force. I think the only tricky thing was to remember that constant speed means acceleration is 0. So all of that becomes equal to 0, and there is your 5 marks. So let's do the next one. The next one says force F is now removed, and the block accelerates downwards on the plane. The kinetic frictional force remains the 2037 newtons. I must calculate the magnitude of acceleration. So now we have the block over here, and now they're telling us that this one is removed. Remember, it still is on a rough surface, so then it starts moving all the way the other side. So now we know what's making it move down is gravitational force, but Fg parallel. Remember, it's still on a rough horizontal surface, so kinetic friction moves from this side and it comes on this direction. So now that's the only two that's working on it now, because we've removed the constant applied force. So I just want to take it a little bit of a notch up in case you are a little bit lost. So now it's moving in that direction, just want to remind you. So my frictional force is always opposing motion. So now my kinetic friction moves in that direction. Now gravity says come down, block, but Fg parallel will then move the block. Now they want us to calculate the magnitude of the acceleration. So now remember, again, it is for 4 marks, Newton's law's formula first. We're always going to say F net is equal to ma. Now they do say it accelerates, so now it's not equal to 0, so acceleration will have a value. So now I can see I'm going to say Fg parallel minus kinetic friction, because they are opposing each other, is then equal to ma. Let me just take it one step longer. Ma. So you can decide where you want to take it from. Fg parallel, I calculated in the previous one. We got 30, 39, 32. But let me do it again. Remember, it's mg sine theta. They did say that doesn't change. It remains the same. So it's still 2037. The mass is 8, and I'm looking for my A. Remember, where I got this one, I just used the one that I got here. So I already have that value. And it is 39.2 minus 20.37 is equal to 8A. So let me do that one quickly. So 39.2 minus 20.37. And therefore I get 1883, and I must divide that by 8. Let me do it the long way around so that everybody knows where I am. 83 is equal to 8A. I need to find my acceleration. I divide both sides with what is bothering the acceleration. So this and this will then cancel. I'll be left with acceleration on this side. So I'm going to take that divided by 8. And therefore I get 2.35. And that will then be my acceleration. This will be 2.35. Remember, the SI unit for acceleration is in meters per second squared. So I think one of the interesting ways in which the examiner actually put a twist to this one is to say that the forces that are applied, remember the force was applying a force going in that direction, it's now removed and the block accelerates down, right? It accelerates down the plane, and then the kinetic friction remains, meaning that the kinetic friction actually changed direction. What do I mean by this? I'm just going to go up a little bit more. Initially, when there was an applied force, the kinetic friction and Fg parallel was in the same direction. But the minute we say this one goes away, kinetic friction says, oh my word, I must now oppose motion. And then kinetic friction now moves in this direction. So now that is one way that the examiner could have caught you out. But we do know that if you are pulling it with a force, once that is removed, then there's no constant force anymore. Then gravity is the only thing that's actually working on that. But then we've got kinetic friction who will always oppose the motion, right? It was first moving in downwards position, then it moved in the upwards position. So the examiner wanted to see that you understand that kinetic friction can actually change direction based on where the applied force is actually working. Which actually makes sense, because the examiner first gave you a little bit of a hint over here to say that you must state Newton's law, right? It's an object that that continues in its state of rest or uniform motion, we were pulling the block with a uniform motion along with a constant velocity and unless acted upon by unbalanced force. So we were pulling it at a constant force, we remove the force, that's not a little bit unbalanced, then the frictional force changes direction. So the most important thing when you're doing Newton's laws, well, it is actually to know the definition for one. I've also seen definitions where they ask you to actually define kinetic friction, static friction, normal force, gravitational force. So there's a little booklet that most of the grade 12s actually have, and in grade 11 that you also got. So I would say go through all those definitions. And then how I always teach my kids, always draw yourself a picture. Sometimes they can give you a scenario, but most of the time they give you a diagram. So the best thing that you can do is draw a free body diagram for yourself. That's the only way that you're going to understand it. And then you're actually able to see, oh, okay, these are two vectors in the same direction or two vectors in opposing direction and so forth. And then you are able to. Another tricky one, the minute you see two blocks with a pulley system, you have to know, it's actually a simultaneous equation. The examiner is trying to catch you out like that. Remember to take your time, and whatever you do must make sense. It must be logical. If you've never seen your teacher do it, don't do it. Thank you so much for joining me today. I will see you next week.